Okay, so we've had a think about how much moles of atoms of certain elements would weigh. But what about molecules? Because we don't tend to only work with elements, we tend to mostly work with compounds. So lots of different elements that are all bonded together to make something new. So calculating the molar mass of compounds is almost as simple as determining the molar mass of single elements. There's just an extra step. So you find your molar mass of each of the individual elements that make up your compound, and then you add them all together. But the one trick there is that you have to make sure that you add the right number of each one of those atoms. So for example, for calcium carbonate, I have one calcium atom, one carbon atom, and 3 oxygen atoms in one molecule of calcium carbonate. So remember, that little number tells you how many of the element that's to the left of it there are in the molecule. So that little 3 is on the end of the oxygen, so that tells me that I've got 3 oxygens in calcium carbonate. So I need to add the atomic mass or molar mass of 1 calcium at 40 grams per mole, 1 carbon at 12 grams per mole, and 3 oxygens each that are 16 grams per mole. So I add all of those together. So 40 plus 12 plus 3 times 16 gives me 100 grams per mole. So that means that if I had 100 grams of calcium carbonate, I would know that I had 1 mole of calcium carbonate, or that I have 6.022 times 10 to the power of 23 molecules of calcium carbonate in that 100 gram sample. So again, give it a go. So make sure you count how many of each atom you have inside your molecule, and that you account for that in your calculation. So for this first one, silicon dioxide, you want to make sure that you have got 1 silicon atom in your calculation and 2 oxygen atoms, and that you add all of those molar masses together from your periodic table to give you a total for the compound. So I'll give you a 3, 2, 1, pause the video, and then come back for the answers. So 3, 2, 1, pause. Okay, answers. We have silicon dioxide, 28.1 grams from the silicon, plus 2 times 16 for the oxygen gives 60.1 grams per mole. Nitrogen gas, 2 times 14, because each nitrogen in that molecule is worth 14 grams, gives 28 grams per mole. Potassium sulfate, so this one's pretty tricky. We've got 2 potassiums at 39.1 each, 1 sulfur at 32.1, and 4 oxygens at 16 each, which gives us 174.3 grams per mole. Water, 2 hydrogens and 1 oxygen, gives us 18 grams per mole. And finally, nitrate, so the nitrogen is worth 14, the oxygen is worth 16 each, and we have 3 of them, so 14 plus 3 times 16 gives 62 grams per mole. It doesn't matter that there is a charge on that molecule, the molar mass will still be the same.